Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the IGCSE chemistry topics. This is electrolysis. I'm going to begin with the general definitions. Electrolysis is a chemical change that is caused by passing an electric current through a compound that is either molten or in aqueous phase. We can see electricity is going to pass through and then the ions are going to separate in this electrolyte. An electrolyte is a liquid or solution that undergoes electrolysis. These are electrodes. We have the positive and the negative ones. So these electrodes are terminals through which electricity is going to be passed out. And we have a cathode as well as an anode. A cathode is the one that attracts the cations, so that means the cathode is going to be negatively charged. The anode is the one that attracts the negative ions, so this is going to be positively charged. These two are electrodes. During electrolysis, reduction and oxidation do occur. Reduction is when electrons are gained by something, and oxidation is when electrons are lost. You can use the mnemonics RIG, meaning reduction is gain, as well as OIL, meaning oxidation is loss. Again, during electrolysis, we need to know a reducing agent and an oxidizing agent. A reducing agent is the substance that gets oxidized. We call it a reducing agent because it causes the thing it reacts with to be reduced. And this oxidizing agent causes the thing it reacts with to be oxidized, meaning the oxidizing agent itself is going to be reduced. Because oxidation and reduction do occur during electrolysis, we can say a redox reaction takes place. So here we have an example. We can see the two electrodes. These are electrodes. This is the electrolyte. We can see the connections to the outer circuit, and the molten electrolyte, this contains ions that are going to be moving. If there are positive ions in here, they will go to the negative electrodes, and the negative ions are going to go to the positive electrodes. Examples of reactions we have here. For the reduction reactions, it means that Pb2 plus will gain 2 electrons to become Pb, which is lead solid, or sodium will gain 1 electron to become sodium. This is a solid, meaning the sodium solid is going to be formed at the negative electrode. Remember, these electrodes used are both carbon because carbon is not going to interfere with the electrolysis. The next one is oxidation reactions. Here we see O2 minus is going to give us oxygen by losing 2 electrons, and bromide giving us bromine by losing 2 electrons. The first example is electrolysis of molten compounds like sodium chloride. Because this is molten, it means sodium chloride has been melted and there is no water here. So in here, we're going to have sodium cations and chloride anions, many of them. But the sodium cations are going to be attracted to the negative electrode, while the chloride anions are going to be attracted to the positive electrode. To melt sodium chloride, we're going to heat it to higher temperatures. The ions are going to be free to move within the electrolyte. And if power is connected to the electrodes, these electrodes are going to be charged, meaning this is going to be positively charged and that is going to be negatively charged. And again, you can ignore this solution because here we're talking about the molten compound. So it's just going to be in a liquid state or melted state. Products are going to be formed at the electrodes. This could be gases or depositions could be formed. The positive ions in the solution are going to be drawn to the negative electrode, and the negative ions are going to be drawn to the positive electrodes. And at those electrodes, reaction occur where the positive ions could form solids that are deposited, or gases could be formed at those electrodes. Looking at electrolysis of aqueous solutions, we're going to have a contribution from water because water has ability to be ionized. It can become H plus, plus or H minus. That means we're going to have 2 cations and 2 anions. For example, for the cations, we will use the reactivity series where we will consider the position of hydrogen. In solution, since we have hydrogen, we will look at the other cation that is present. If it's below hydrogen, then that cation is going to be formed as a solid. But if it's above hydrogen, then hydrogen is going to be formed as a gas at the negative electrode. And again, remember the reactivity series is going to be used to determine which cation is going to react at the negative electrode or which cation is going to be preferred. For the anions, remember we have OH minus from water, but also we could have another anion from the actual substance that has been dissolved in the water. If there is a halide, a halogen is always going to be preferred to be formed at the anode. But if there is no halide, it means we'll have OH minus in some other complex ion like sulfate, nitrate, phosphate, and so on. The OH minus is going to be preferred, and in this reaction, OH is going to be used to produce oxygen at the positive electrode. Let's look at the first example, electrolysis of copper 2 sulfate solution. In the copper 2 sulfate solution, we will have copper 2 plus, we will have SO4, 2 minus, H plus, or H minus because all these are present. Because copper is below hydrogen in the reactivity series, it means copper is going to be preferred. That is why we see copper forming at the negative electrode. Now these are going to remain, so we're going to go with the OH minus that is going to be reacted to produce water and oxygen. So this gas is going to be evolved at the positive electrode, while the copper solid is going to be deposited at the negative electrode. When this occurs, the blue color is going to become pale blue because the copper 2 plus, which makes the solution blue, is going to be used up or is going to be decreasing, and the intensity of this blue color is going to decrease. This is a common question in the exams. Now looking at the summary, for example, if they talk about sodium chloride solution, here we will have the sodium plus, chloride minus from the sodium chloride, and the H plus or H minus from water. Here, hydrogen is going to be produced because it's below sodium in the reactivity series. So at the negative electrode, hydrogen is going to be evolved, we can see that. And at the positive electrode, chlorine is going to be formed since a halide exists, which is chloride. For copper 2 sulfate, we have copper, we have sulfate, we have hydrogen and OH minus. I've already gone through this. Copper is less reactive than hydrogen, or copper is below hydrogen in the reactivity series, so copper is going to be preferred. And here, OH minus is going to be preferred and oxygen will be produced at the positive electrode. For magnesium bromide, we see there is already a halide, so bromine is going to be formed at the positive electrode. And then we'll have the cations magnesium and hydrogen. Magnesium is higher than hydrogen, so hydrogen is going to be preferred and hydrogen gas is going to be evolved at the negative electrode. For sulfuric acid solution, we will have a hydrogen from sulfuric acid as sulfate and a hydrogen from water and OH minus. So automatically here we're going to form hydrogen gas at the negative electrode, and here we'll form oxygen at the positive electrode because OH minus is going to be preferred. To understand electrolysis of aqueous solutions, you have to know the reactivity series because it's used to find out which cation is going to be preferred. And for the anions, if there is no halide, then oxygen is going to be formed at the positive electrode. So this brings us to the end of this video, which is about electrolysis. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.